Alright, hello everybody. So probably a lot of you guys have come from SHPE's Dia de Ciencias event, which is a really fun event, and probably a lot of you have come because we didn't get to finish our workshop on the building of prosthetics in CAD, specifically Inventor. As I said, CAD is awesome because engineers, not even just engineers, a variety of people can use CAD to generate a 3D model of whatever prototype they want, and then they can actually 3D print that model out and actually make a physical model. So that's really cool. So imagine you can make a prosthetic in Inventor and just 3D print it. That's actually what you can do. So this is a continuation of what we were trying to show you guys in our workshop. And just to remind you, we were trying to create this cheetah blade. Alright, so you'll notice that from the side-by-side picture that it was trying to mimic the structure of an actual cheetah, which a lot of us know that it is a very fast animal. And naturally, this prosthetic tries to or is fit for somebody who wants to run and sprint around. And this picture here shows a variety of those cheetah blades. And you'll notice that in every single one of them, even though they have slight differences, they follow this signature J shape, right? So this is very good if the person wants to push down on this and basically spring off of that foot. So that is what we were trying to make. And before we create a single point or single line on CAD, it's a good idea to try to make a rough sketch, a freehand kind of sketch. So I really just tried to, obviously it's not perfect, but that's why it's a rough sketch. I tried to make roughly what I would want from this cup. So a couple things you'll notice, I drew the cup, and I drew this kind of J shape of the cheetah blade, and most importantly, you'll see that I've added some measurements that I've determined need to be in the prosthetic. For example, maybe I know that the person who's to wear this prosthetic has their amputation site about 3 inches in diameter, and will probably also know the height of the bottom of the amputation site to the ground. Probably that's 8 inches, or in this case it is 8 inches. So this is clearly very small. It's not for a human really, but that's just for the purpose that if you have a small 3D printer, you'll be able to 3D print this thing. And so yeah, we can get started once we have an idea of what we want to make on Inventor. This is a very good guide. By the way, maybe some of you have noticed that the YouTube channel, it has another cheetah blade tutorial, and this is kind of just this tutorial is following the basics, or trying to show the basics of it. But if you want a more sophisticated kind of college level explanation, well, don't be intimidated by me calling it college level. Anyone can try to follow with it. You can go to that video. But I tried to cater this tutorial to middle schoolers and high schoolers who were our audience for today. So first off, we want to start a 2D sketch. Well, before that, you probably haven't opened Inventor yet, or maybe you have, but now you need to open up a part file. So sometimes it'll pop up after clicking new, it'll pop up this window. You just make sure that it's in English units, and since that's what we're working with, and then you double click on standard IPT. Alright, so anyways, with that out of the way, you'll be able to open up this, and after starting a 2D sketch, click on the XY plane. So the first thing that we did was designing a cup. This is what's going to be holding the amputation. So as I mentioned before, if we slice this cup in half, we get a sort of U shape, right? So we're going to be making half of that cross section. So the way we can do this is we can go down to arc, go down the drop down, and hit center point. So now we're going to place the first point somewhere along the positive y-axis. So it doesn't really matter for now. And then we go down until we reach the origin. And then so it's asking us to kind of like where we want to sweep this arc. Go ahead and type in 90. You can do that since that text box was highlighted. So now it sweeps only a 90-degree angle. Now we're going to make our second arc. So again, click on the first point that you made. Make sure it's directly on it with the green dot. Go down and don't hit the origin this time. Be a little more vertically up, or just up, yeah. So just click somewhere, and then again type in 90 degrees. So now you can see we're kind of getting our cross-section shape where this has an actual thickness. Just go ahead and close off this shape by hitting the line tool and then clicking on one point of the end of the first arc and then click on the second point, a second arc ending. Do the same, close off this part of the arcs, and voila. So that is half of our cross section. So you might be wondering how this little thing can turn into a cup. Well, that's when we finish our sketch and then we hit the revolve feature. So you can see that it automatically selected our closed profile for us, but now we have to select an axis. So what the revolve feature does is it creates multiple slices of this closed profile rotated along a certain or rotated around a certain axis. So in this case we're going to be selecting this dotted line here, which is on the y-axis, and there you go, it rotates the whole thing, this cross section, across around the y-axis, and that's great. So now we have our cup. Now this cup isn't going to be enough to hold on to the person's leg, right? Like this is kind of just like, you know, like a little bottle cap thing. So it's not enough. Let's add some height to it. So you can start your 2D sketch on top of this cup, and then select the face, this like ring area here. You saw how, I just delete it. You saw how it was green. Select highlighted in green, this ring. So start your sketch there. Then what you want to do is you actually don't need to produce it or try to sketch anything at all. Hit project geometry, select the outer ring, and then the inner ring. So a common mistake that people did is sometimes they selected like this whole thing when they were really just trying to select the inner ring. Don't do that, because that just makes it select the whole circle, and we don't really want that. We just want this face. I think alternatively you could just select this, as long as it's only highlighting the ring part. So yeah, that's fine. Now it's highlighted in yellow. And so we hit finish sketch, and then we go to extrude. It wants us to select the profiles. Go ahead and select the profile that we just projected, highlighted in green. And you can, by the way, double click the middle mouse scrolling button to automatically zoom it out to fit your thing. And then you can see that it projected it extruded that part of the thing up. There's no like, you see that the hole remains. Actually, I do want to do one thing before I forget. So, sorry. Let's go back to our revolution, our sketch that we revolved. So the way you can do that, you can hit the plus button, and then you can double click on your sketch. So, like I mentioned before, we know the diameter of the person's amputation to be 3 inches, right? So we can actually define this measurement, this radius of the cup. So we go from this point, that kind of like the inner corner of the arcs, to this dotted line, vertical dotted line here. And what this does, it measures the horizontal distance. And again, we know this measurement to be 1.5 because that's the radius. 3 divided by 2. You could also just type in the math here. And then again, just double click the mouse wheel. You can see now it is it adjusted everything accordingly to our radius. So yeah, forgot that part, and I'm just going to redo what I did before, which is again adding some height to this. Start 2D sketch on this face, projecting the geometry, and then extruding it upwards after selecting it, of course. So let's say like we want 2 inches, I don't know. Let's go crazy. Okay, so awesome. Now it actually has some sort of structure to kind of hold the leg. Okay, that's great. Now it gets a little trickier maybe for some of you. So or not some of you, maybe a lot of you. So we go down to the plane drop down menu and we hit tangent to surface and parallel to the plane. So we want this, we can't simply use the 2D start 2D sketch tool to create a sketch along this cylinder. It's not flat. So what we have to do is we have to create a flat plane to allow for the sketch to happen. So again, go down the plane, tangent to surface and parallel to plane. We want it to be tangent to this very curved surface. That means that we want kind of like our plane to touch at one point of it. But at the same time, we want it to be parallel to the XY plane, for example. So what it does, you'll see here, it does exactly that. So it's touching the curve at exactly where we want it. That's great. So, okay. Now let's start a 2D sketch on this thing now. So I'm just gonna make a simple little rectangle, and again, we're not gonna go as much into detail probably as with the other tutorial, just for the sake of covering the basics. But if you really want to know more about constraints, because constraints are very important, so you can go to the other tutorial. But in this case, we're not too concerned about dimensioning every single thing, making sure that we're constraining it to this position by locking it into XYZ. But yeah, so anyways, I want you to draw a rectangle. You can click any point on this thing, and again, we're not concerned about like the width, but maybe I think we should have this rectangle go down to the bottom of the cup. Okay, so this is awesome. Now we're gonna go over probably 2 constraints this tutorial. So one of them is the horizontal constraint. We want to make sure that this is centered. This is, how do I say it? Horizontally aligned with the center of the bottom of the cup. That makes sense. So again, horizontal constraint, and then click on this. Be very careful. Click on this little yellow dot, and sometimes it takes a few tries. Again, I'll click on the I'll hover over this top line of the rectangle until I see the green dot, and then I'm gonna hit this yellow line. Maybe I have to zoom out. I don't think it's okay. Well, yeah. So it actually is the vertical constraint. Not sure why last time I did it, it was working with the horizontal constraint. So let's finish our sketch anyway. Let's extrude this feature so that it's a 3D feature. Let's say, like, I don't know, it's not that thick. Let's say 25 inches. Let's say 35 inches. Yeah, why not? So yeah, make sure it's extruding in this direction. So now we have our little bar part here, like how we have this straight part here. Okay, so now we're going to start another 2D sketch, and this is gonna be actually our J shape. So start 2D sketch. Make sure that the camera is facing on the side of this rectangular bar. So you have this view cube over here. You could just select the face of the camera that you want. So start your 2D sketch, select this whole face, and then it creates a sketch on that plane. Okay, so now what we want to do, we want to create our arcs so that we can make the J shape. So we're going to make an arc, a 3-point arc, starting at the bottom corner of this rectangle, this bar. And so we just click, and then let's click somewhere over here. I'm not sure why I didn't click. Okay, and then let's do somewhere over here, so that's kind of curvy. That looks fine. And then let's make another arc from the last point that we clicked to here. Okay, so this looks okay. Let's constrain it. So this is the second constraint feature I was talking about, tangent. So you can see there's a little bit of, you know, roughness, a bit of jaggedness here. So we're going to smooth this out by hitting the tangent constraint and clicking on the two arcs we made. Now it's a lot smoother, you'll see. And so you'll see that it looks a lot more similar to our J shape that we want. So you'll notice that I can also still modify this. It's not constrained or anything. So I can just click and drag the arcs as I like. Maybe I want this bigger, or taller, or smaller. Maybe I want, I don't know, it to be more rounded. Maybe I want this to go further to the right. I can edit this little point, just move it. Okay, so now we have our little arc here. So now let's try to define the height from this to this. Like, if you remember, we know the height from the bottom of the amputation to the ground to be 8 inches, right? So we're just assuming here that this is kind of like the bottom of the amputation, though that's not exactly accurate, or it's just an assumption. And then this would be the bottom of the or the lowest point of the cheetah blade, and it's the case for here. You'll see it's kind of just flattened at this point. Okay, so let's see. Let's dimension from this little point to this little point at the end of the arc, and again it's 8 inches. So that looks pretty good. So I'm just gonna adjust it, like I said, a little bit, and you know, just be a little careful because again, it's not exactly the lowest point of the thing, of the arc. Okay, so now we can just offset this arc, and what this allows us to do is kind of just move it, duplicate it and move it. So let's say I'm not too concerned about the thickness. Let's say we want 0.65 inches of a thickness. So now we have a pretty thick arc, and then we can go to the line tool. We can select this inner corner of the rectangle, and just basically just kind of close this part off. Okay. Again, just adjust it like as you see fit. Okay, so maybe I want this out more or something. Yeah. Okay. Look good. Now I want to extrude this, make this an actual 3D feature. So I hit the extrude function, and then I make sure it's going in the right direction first of all. So I flip it, and then let's say I don't remember how wide this rectangle is, so I could just select 2 and then hit this edge of it. Automatically makes it as thick as this is wide. Okay, so now we kind of have a rough sketch of our cheetah blade. And you can still, like I kind of showed you earlier, make modifications even after finishing the sketch by double clicking and going into the sketch. I think I'm okay with this. I will add some fillets just to finalize this 3D model. Now fillets aren't just aesthetically pleasing and get rid of sharp edges, but I think they make the structure a lot more structurally stable. Go into fillet. So let's say we want maybe 1/4 of an inch of a fillet. So that looks fine. Let's do these edges too maybe. And then let's do this edge. It looks quite sharp. And then last of all, this. Oh, actually not last of all, this one as well. So now this is looking pretty okay. So let's go to view and let's just see how it looks without like the lines, and we'll go to realistic. This is probably what it would look like in real life. What do you think? We have the cup holding the person's amputation, and then we have the cheetah blade. So this won't be the final model. There's a lot of stuff that we could do post 3D printing. We can add foam inside the cup to make it more comfortable to wear for the person wearing it, because having your skin just be touching hard plastic all the time is I imagine very uncomfortable. We can also add rubber on the bottom of this foot so that there's more friction. It's easier to run at the same time stay in place. So yeah, congratulations, you made your first prosthetic, and I hope you're happy with the result. There's a lot more potential for using CAD softwares. I'm sure that we'll see so many great things come out of you using softwares such as these, or maybe even using stuff outside of this software. Really, it's up to you. So I hope this was interesting to you. I hope that you had fun making it, and I hope that you can feel free to contact us, the Prosthetics Club, for anything, whether it's engineering advice or, just stuff about prosthetics, about animals. But yeah, I thank you so much for watching and for attending SHPE's event, and I hope you have a good one. Thank you.